is diagonalization of matrices. Diagonalization is particularly useful in simplifying complex computations such as finding powers of matrices. Actually, in diagonalization we have to find a diagonal matrix which is P inverse AP. Here A is our matrix to find the to do the diagonalization, and for that we have to find P inverse AP which is equal to D. It is a diagonal matrix. This diagonal matrix have the diagonal elements as eigenvalues of A. So we can say that for a given square matrix P, the process of finding the matrix P such that P inverse AP equal to D is called the diagonalization of matrix A. We can do a problem, then we will get the clear idea about the diagonalization. For that, our problem is diagonalize the matrix A. A matrix is given with 3 rows and 3 columns. We have to diagonalize the matrix A. First, we have to find A minus lambda I. Here A minus lambda I means lambda is a matrix with this is the lambda matrix. Then A minus lambda I means we know that it's an identity matrix with the elements 1. So A minus lambda I is equal to 1 minus lambda. The next element is 1, 1. Then 1, 1. So the diagonal elements will change to 1 minus lambda, 2 minus lambda and 3 minus lambda. All the elements are same. All other elements will be the same. So we will get A minus lambda I. So first step is we have to find A minus lambda I. Then we have to find the values of lambda. For that we have to do a calculation. Here the calculation is, for that we have to do a calculation. The calculation is lambda cube minus trace of A lambda square plus m11 plus m22 plus m33 into lambda minus determinant of A equal to 0. When we are solving this equation, we will get the values of different values of lambda. First, we have to note what is trace of A. Trace of A is nothing but the sum of diagonal elements of matrix A. Here diagonal elements of matrix A is 1, 2, 3. So the sum of diagonal elements will be 1 plus 2 plus 3 which is equal to 6. This is the trace of A. Then what is M11? M11 is the matrix which we have to eliminate first row and first column and first row. Then the remaining element will be 2, 1, 4, 3. So 2, 1, 4, 3. When we are finding the determinant of this element, we will get M11. Similarly, M22, we are eliminating second row and second column. Here the second row and second column, when we are eliminating, the other elements are 1, 1, minus 4, 3. So we are finding the determinant of this element, we will get 3. Similarly, we can find M33. That means eliminating the third row and third column. So we will get the elements third row and third column 1, 1, 0, 2. That means we will get the determinant of this element, this matrix, we will get 2. So this we got the elements 1, 1, 1, M22, M33. Then we are adding here this. Here we will get 2 plus 7 plus 2, we will get 11. So 11 lambda minus determinant of lambda A. Determinant of A we can find using calculator, otherwise we can do calculation. Determinant of A we will get minus 6. So we can substitute these values in this equation. We will get lambda cube minus trace of A 6 lambda square plus 11 lambda minus 6 equal to 0. When solving this equation using calculator, we will get the different values of lambda as lambda equal to 1, 2, 3. Then next step is, then we are substituting each element of substituting the each value of lambda. First, lambda equal to 1. When we are substituting lambda equal to 1, lambda equal to, when substituting lambda equal to 1, our matrix A minus lambda I, we are substituting the value lambda equal to 1 here. So here the matrix will be 1 minus 1, 0. The next element will be same 1, 1, and the here 2 minus 1, which is equal to 1. Then 3 minus lambda, 3 minus 1 equal to 2. So our matrix will be 0, 1, 1, 0, 1, 1, and minus 4, 4, 2. And then matrix A, the variable x1, x2, x3, and 0, 0, 0 matrix. That means we are doing Ax equal to 0. So we can write the equations by back substitution. 0x1 plus 1x2 plus 1x3 equal to 0. Then 0x1 plus 1x2 plus 1x3 equal to. When substituting lambda equal to 1, our matrix will change to A minus, we are substituting the matrix A minus lambda I into x equal to 0. Here lambda is equal to 1. So our matrix 1 minus lambda, 1 minus 1, 0. 2 minus lambda, 2 minus 1 equal to 1. Then 3 minus 1 equal to 2. So our A minus lambda I will be like that. And then the x is the variable matrix, x1, x2, x3. 3 rows. So we have 3 variables. Then which is equal to 0. Then we are writing these equations, this matrix into equation form. Here 0x1 plus 1x2 plus 1x3 equal to 0. Next 0x1 plus 1x2 plus 1x3 equal to 0. And minus 4x1, 4x2 plus 2x3 equal to 0. Then we will get 3 equations. From these 3 equations, we have to find x1, x2, x3. For that, we are taking 2 dissimilar equations. Then from this equation, we have to take 2 dissimilar equations. 2 dissimilar equations mean if 2 equations have common multiplier or common divisor, we can neglect that equation. Only we have to consider only one equation from that. So here these are the 2 dissimilar equations here. These 2 equations are same, so we are taking equation 1 and 3. From equation 1 and 3, we have to find x1, x2, x3 by Cauchy-Riemann equation. For that, x1 divided by x1 by, we are taking the elements by negative. Here, x1 divided by determinant of the matrix which have no x1 coefficient here. 1, 1, 4, 2. These are the elements of this matrix, and find the determinant, which is equal to minus x2 divided by the elements which have no x2 term. So 0, 1, then minus 4, 2. These are the elements. Then equal to x3 divided by the elements which have no x3 coefficient. So here 0, 1, and minus 4, 4. When simplifying this equation, we are finding determinant of each term. Then we will get x1 by minus 2 equal to x2 by minus 4 equal to x3 by 4. So there is a common term in this. So we are simplifying again. x1 divided by minus 1, x2 by minus 2, and x3 by 2. We can represent this term as x1 equal to minus 1, 2, minus 2, 2. This is the first eigenvector. So we got x1 is equal to minus 1 minus 2 2. Similarly, our next eigenvalue is lambda equal to 2. So next we are substituting lambda equal to 2 and finding a minus lambda I x equal to 0. Then similarly we are finding x2. x2 is equal to, we will get 1 1 0. Then next lambda value is 3. So lambda is equal to, when substituting lambda equal to 3, we will get x3 equal to 1 1 1. So we are representing these three elements, three eigenvectors in a matrix form as matrix P, model matrix P. So our first eigenvalues will be, first eigenvector was minus 1 minus 2 2, and next eigenvalue vector was 1 1 0, and next was 1 1 1. So these elements is represented as a matrix P. So next we have to find P inverse. We know that for P inverse, our finding P inverse, our equation was adjoint of P divided by determinant of P. We can find it using calculator. Then substituting this element, we will get P inverse. Then our diagonalized matrix D is equal to P inverse A P. P inverse we already found here. Then A is a matrix which is in question, and P is our model matrix. So when we are substituting this in this, we will get the doing this calculation P inverse into matrix A and this matrix into P, we will get the matrix which is diagonal elements as our eigenvalues, which we got already lambda equal to 1 2 3. These are the diagonal elements of the matrix 1 2 3. This is our diagonal matrix D. So we diagonalize the matrix. So we diagonalize the matrix A 1 1 1 0 2 1 and minus 4 3. This is diagonalization.